Okay, in this video we're going to show you a challenge problem involving free fall. This is problem 47 in your book, page 41. I notice the 3 means it's a challenge problem. Okay, so in this problem we have a stone that's thrown vertically upward with a speed of 12.0 meters per second from the edge of a cliff 70.0 meters high. Two things we got to figure out. A, how much later does it reach the bottom of the cliff? So how long is it in the air is another way of asking that question. And then B, what is its speed just before it hits the ground? And finally C, what total distance did it travel? So this is a challenging problem. There's lots of stuff going on here. All right, let's start with our diagram and our givens. Okay, so I already drew this out a little bit. So let me make sure we're focused in here. Okay, there we go. All right, so what I'm given in this problem is the initial velocity of 12.0 meters per second. And it's thrown upward. Remember, up is going to be positive, down is going to be negative. So an upward velocity is a positive velocity. We also know that the height of the cliff is 70 meters. So from where the ball, and this really should be to the ball, make that perfectly clear. So from the place the ball starts to where it lands, remember, ground is 0. Height of 70 means I'm starting in a positive position and I'm moving down back to 0. So my delta x is negative 70.0 meters for the whole flight of the ball. And it's in free fall. As soon as it leaves their hand, the acceleration is negative 9.8 meters per second squared. So these are the 3 things we know for sure about the ball. And we have a number of unknowns we need to solve for. Maybe I'll just, we'll spread them out once we got enough room to do this. Unknown for A is, what is the, let me look at it again, how much later? What is the total time? It's in the air. The unknown for B is how fast, what's the speed before hitting? So V final. And for C, it is total distance traveled. So distance, not displacement. That's going to be a little challenging. Okay, let's look at the first one, total time. How can we find the total time it's in the air? And this will give us a chance to show you how in projectiles or projectiles free fall, things that are flying through the air, how we can solve for total time using the quadratic in a couple different ways. Because if we look at an equation to pick out, I'm going to slide this one over here, to solve for time. I can't solve for it using this because I don't know final velocity yet. This doesn't have time. I suppose I could use this to find final velocity and then go back to find time. So you could do a 2-step. But I want to show you how we can use the second equation to very easily, or very quickly, find time, even though this is in the quadratic formula format where we have the t and the t squared. So let's set it up with equation 2. Delta x is v naught t plus 1/2 a t squared. So because v naught's not 0, now v naught is 0, you can simplify this term and solve for t squared. But when you have a v naught that's non-zero, like 12, I'm going to have a t term and a t squared term. So I got to use the quadratic. So let's set it up. My delta x is negative 70.7 meters. My initial velocity is 12.0 meters per second times the time plus 1/2 times negative 9.8 meters per second squared times t squared. So if I simplify this and put it in quadratic format, I'm going to have, let's just send, let's send these over here. So I have 0 on one side and all the terms on the other. So I have, this is negative 4.9 meters per second squared t squared. So I'm going to send that over, positive 4.9 meters per second squared t squared, so that's my a term, and then I'm going to send this to the left, so that's going to be negative 12.0 meters per second t, and then minus 70.0 meters equals 0. Okay, so if you're interested in doing this longhand, what you've been taught at some point, you know that in solving the quadratic, t is our variable. You could use the old formula negative b plus or minus the square root of b squared minus 4ac over 2a, right? And in this case, this is a, this is b, and this is c. And this works perfectly fine, okay? So let's do it. Negative b is negative negative 12, which is 12, plus or minus. I'm going to leave the units out so it doesn't get too crazy here. Negative 12 squared, and then minus 4 times 4.9 times negative 70 over 2 times 4.9. Okay? And if you simplify this, you get 12 plus or minus. This term should give you, let's see, let me double check it because I had different values in here before. So I have 144 and then minus, but this is a minus here, so minus a minus will be a plus, plus 4 times 4.9 times 70. And I'm going to square root that. So 38.94 basically. And then all over 9.8. Okay, so 12 plus 38.94 gives me a positive. 12 minus will give me a negative. I can't have a negative time. So it's going to be the 38.94 plus 12 divided by 9.8. 5.197 equals 5.1975. I won't round it off yet because I'm going to use that to find other bits of piece of information. So that's the long way you can do it. I'm going to show you two other ways. The first being by plotting this. You could plot this quadratic, and if you plot it and look at the value when it crosses the x-axis, or when you set this up equal to 0, you can see at what time does this equal to 0 via the graph. So if you go on your computer or your calculator, you go to your stat plot, turn those off, but under your y equals now, you enter your formula. And instead of using t's, you use x's. It doesn't matter. It's the same idea. So I had it as 75 before from my old version. So 4.9 t squared, x squared, minus 12t x minus 70 equals, and I'm going to set a y2 equal to 0. So I'm going to have two lines. I'm going to have the quadratic plotted and y equals 0 plotted, and then I'm going to be able to look at the intersect. So if I graph this, okay, so there's my quadratic, and I'm going to have a line plotted at y equals 0, which you can't see. Now, what I can do to find what is this value, what I want to know is what's the value when this quadratic equals 0, at what time, at what x. So if you go to second calc, intersect, you can find the point at which those two lines intersect. And it'll say first curve, you say yes, hit enter, second curve, enter. And here, the intersection of that line is 5.1975, right? Seen that before? 5.1975 seconds. So it's the same exact answer. So it's a quicker way. Sorry, it's not, the screen's showing you a little glare, but that's a quicker way using your TI to find the value of the quadratic. Now there's the other way you can do it and I don't have it on the 83 here, but on the 84s and above, there's the Poly Smelt, I think it's called, program, which is a root finder for quadratic equations. So you can do that. It gives you the two roots. If you're familiar with using that, I'm sure plenty of you have done it before in your math class, if not all of you. So that's a third way. So when you have a quadratic, I give you 1, 2, 3 ways to solve it. Neither is better than the other. Whatever you want to use is up to you. All right. So there's our time. So we now have the time 5.2 seconds. I'll round it off there. All right. How fast is it going when it hits the ground? B. Well, now I want to solve for V. Once you find the first thing, the time in the air, the whole world is open to you in terms of equations, right? It's a lot easier now because now you have time. So you really have more options. So let's go with the simplest one, which will be equation 1. I'll go blue for this one. My velocity final at some point in time is equal to my initial plus AT. So my initial is a positive 12. You got to be careful. A positive 12 meters per second plus, now it's going to accelerate at a rate of 9.8 meters per second squared negative for a time of 5.2. The whole time it's in the air, it's accelerating downwards. So that's my total time. So I have 12, and then this is a minus and a plus. This will be minus 12 minus 9.8 times 5.2. So velocity final is negative 38.96 meters per second. Notice negative. Negative means the ball or the rock, whatever it is moving downward when it hits the ground. Okay, one more. Go back to black. The last question was, what is the total distance the ball travels while it's in flight? Okay, now this one's a little bit more challenging, okay? Because the only distance we know is this 70 meters that it travels from where it reaches back to where I threw it to the ground. But I don't know the height that it reaches its peak max, because if I throw it upward, it's going to reach some peak height and then fall back down. So I got to find the distance it takes to get to its highest height, and that will then allow me to find the total distance that it's in flight. So in order to do this, we need to know something. So I'm going to model this just as straight up to its peak, and I want to know this height, this delta x. Okay? So I got to be careful in what information I can use. I still know that A is negative 9.8 meters per second squared. I still know that V naught is positive 12.0 meters per second. But I don't know delta x, right? I'm solving that separately. What do I know though? I know by the time it reaches its peak, it changes direction, right? And when it changes direction, its velocity must be 0. You throw a ball up in the air. It's going upward, losing velocity, stops, comes back down with a negative velocity. So during that change of direction, it had to have crossed the axis where velocity is 0. So from this, can I find my delta x? Right, these are my new givens unknown. And so we go back to my equations. Well, VVA delta x, boom, equation 3. I can do it in one step. V squared is V naught squared plus 2A delta x. And I want to solve for delta x, so I'm going to subtract this over and divide by 2A. So I get V squared minus V naught squared over 2A is delta x. So 0 squared, right, minus 12.0 meters per second squared over 2 times negative 9.8 meters per second squared equals delta x. All right, so in this case, 12 squared is 144. I'm just gonna write this over here, minus 144, and that's meters squared per second squared over negative 19.6 meters per second squared. So I have a meter squared here and a meters, so that cancels the square. Second squared and second squared, all I'm left with is meters. Negative and negative, so my delta x is 144 divided by negative 19.6. Boom, 7.35 meters. Now, is that my final answer? No, right? This is a long problem. That's just the total height. So I've got to say I go 7.35 meters up and then 7.35 meters back till I reach the point I left, and then the 70 meters after that. So my total distance, I got to take my 7.35. Remember, distance doesn't need direction. 7.35, double that for up and down, and then plus 70. So my total distance is that times 2 plus 70, 84.7 meters. Okay? So there's an example of a challenge problem using free fall, using negative 9.8 as your acceleration, and solving using the quadratic, an example of that. So hopefully this challenge problem really helps you out in understanding how to solve hard problems.